Hello students and welcome to my channel SriRam Edutalks. In today's class, we are going to learn the graphical method of solving a pair of linear equations in two variables. Now the general form of such a pair is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Now here A1, B1, C1 and A2, B2, C2 are any real numbers. Okay. So we have several methods available to solve such a pair of linear equations. One of the method is the graphical method. Now in this method, we plot the straight line graphs of the two given equations on the same coordinate axis, and we may get three possible cases. Let us explore those cases. So case 1 can be the two lines are intersecting at a point. Now you will get the graph of such lines like this as they intersect at the point A having coordinates a comma b. So I will say that x is equal to a and y equal to b is the solution of such a pair. We call this unique solution. Okay, then the case 2 can be that the two lines coincide with each other. Now, the graph of such a situation will be that you will be getting only one line representing both L1 as well as L2. Here we have got infinitely many solutions. And finally, case 3 could be that the two lines are parallel to each other. You will get the graph in this case maybe like this. Here the two lines L1 and L2 are parallel to each other. And important to note here is that as the lines do not intersect anywhere, so we have no solution in this case, because we get a solution only when the two lines intersect with each other. So let us take an example to understand this even better. The two equations suppose given are x plus y equal to 3 and 2x plus 5y equal to 12. So first of all, I am going to prepare a table of values for both the equations, and using that I am going to plot the two lines on the same graph paper. You have to choose at least three values to get a proper line, and you also have to try and make sure that you choose only integral values so that they are easy to plot. For example, in this case, if I take x is equal to 1, I get y equal to 2, and if I take y equal to 1, then I get x equal to 2, and finally I may take x is equal to 0, so I will get y equal to 3. So likewise for this also I am going to take three values, So suppose I take x is equal to 6, then I will get y equal to 0. If I take x is equal to 1, I will get y equal to 2. And if I take suppose x equal to minus 4, then I will get y equal to 4. Next is I will plot these values on the same coordinate axis. So we are already aware of the coordinate axis. So I'm going to plot these lines one by one. Okay. So first I'll plot this x1, y2, x1, y2 is this point, x2, y1, x2, y1 is this point, and x0, y3, x0, y3 is this point. So if I join these three lines, I'll get my graph of x plus y equal to 3. Now let us see this. x6, y0, x6, y0 is this point, x1, y2, now this is a common point, x1, y2, and x minus 4, y4, x minus 4, y4 is somewhere around this. Now this also if you join, as you can see, I have got the point of intersection of these two as x1 and y2. So this becomes the solution of this pair of equations. X is equal to 1 and y equal to 2. Next, let's talk about the various conditions for solvability of a pair of linear equations. So as you can see this table, we have three possibilities for a pair of lines given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So first of all, we are going to see the ratio a1 upon a2 and b1 upon b2. If they comes out to be unequal, then graphically we can say that we have intersecting lines, and algebraically we can say that the given pair has unique solution, also called consistent system. The other possibility can be that a1 upon a2 comes out to be equal to b1 upon b2, and if we check c1 upon c2, that too comes out to be equal. So all the three ratios are equal to each other. Then our two lines are coincident lines, one upon the other. And algebraically, we can say that there are infinitely many possible solutions. Now, this system is also called consistent and dependent system. Finally, the third case could be that we carry on calculating the ratios. A1 by A2 comes out to be equal to B1 by B2, but is not equal to C1 by C2. In such a case, we have parallel lines on the graph, and algebraically I can say that no solution possible, also called inconsistent system. So in these two situations, we have a consistent system, whereas in case of no solution, we have inconsistent system. Also, in case of infinitely many possible solutions, we have a dependent system of equations. That is all for today. We'll catch up again in the next class. Till then, take care, goodbye, and yes, keep watching SriRam Edutalks. Thank you.